Hello everybody and welcome back. Today I have a mechanics of material problem. I hope you have a paper and a pen so we can get to work. Also, if you are interested in any free resources that I have for you, please check the links below this video. Go ahead now, grab yourself some coffee and let's get to work. A composite cable with modulus of elasticity 180 gigapascals, diameter 1 centimeter, and original length 150 centimeters is subject to the following design requirements. Maximum elongation is 2 millimeters and allowable stress 400 megapascals. What is the maximum permissible axial tensile load on the cable? So we have to calculate the maximum load where these two conditions are met. Let's first talk about the modulus of elasticity. If in any problem you're not giving the modulus of elasticity, you can go to your handbook to Mechanica of Materials, and let's try there. And you're giving at the end of this section, Mechanics of Materials, you're giving a few information about the basic materials here. So you have steel, aluminum, cast iron, whatever the problem gives you. If it doesn't specify the modulus of elasticity, you can find it here. Also, it gives you the modulus of rigidity, Poisson's ratio, coefficient of thermal expansion, and density. So don't freak out if you don't have it. Now let's go back and find here the formulas that we need. So this is mechanics of materials section. We need the allowable stress and the deformation. Here, right here, you have the stress formula, which is the load over the area. And then we have also the longitudinal deformation, which is the load times the length over area times modulus of elasticity. So let's go ahead and write these two formulas. And out of these two formulas, we are going to calculate the load. And then the final load, it's going to be the minimum out of these two results. Okay, let's calculate the load due to allowable stress. So the formula says the stress equals to the load over the area. From here, we will calculate the load, which is equal to the stress times the area. Let's calculate the load. So our stress is 400 megapascals. Let's talk about the megapascals and gigapascals here. If you are not familiar with these units, I suggest you go to the handbook, FE handbook, click on the unit section, and you are going to see this little table here. And this mega and gigapascal are going to be explained. So mega is 10 to 6, giga is 10 to 9. All right, going back to our problem, I have 400 megapascal, meaning I have 400 times 10 to 6 times the area. The area of the cable, the cross-sectional area, will be pi times diameter. Let's transform this into meters to be consistent. So we'll have 1 centimeter transform into meter. It will be 0.01 squared over 4, resulting, let's see, 0.01 squared, multiply it with pi, 4 divided. Okay, I'm getting 31,416 newtons. And the reason this is newtons, in here, I'll have pascals and this is meter squared, and pascals equals to Newton over meter squared, which means this meter will, with the meter squared will go away. So you're left with newtons. I hope that's clear. Now, our maximum load is 31,416 newtons. Let's transform this into kilonewtons. I'll have 3142 kilonewtons. So this is the maximum load allowable due to allowable stress. Now let's go ahead and work on the second condition, maximum elongation. Our formula is, go to mechanics of materials, and this is the formula we are going to use. Elongation equals to, or elastic longitudinal deformation equals to PL over AE. Okay, let's apply this condition, equals to PL over AE. Results P equal to deformation times A times E over L. Okay, so we have 2 millimeters, which is going to be 0.002 times the area, which is pi, times 0.01 squared over 4 times modulus of elasticity is 180 times gigapascal means 10 to 9 pascals over the length is 150 centimeters. Transforming that to meters, we have 1.5 meters equal. Let's see how much. Okay, so I have 0.002 multiplied by pi, 0.01 squared multiply 4 divided 180 multiplied 10 to 9 multiplied 1.5 divided. I'm getting 18,849.6. I should have just done 18,850, right? Newtons. And if we transform this to kilonewtons, I will get 18 kilonewtons, 85. Okay. So the final load, in order for these two conditions to be met, it equals to a minimum between 3142 kilonewtons and 1885 kilonewtons. And my final answer is 1885 kilonewtons. Here we go. So I hope this makes sense. When you're given a problem like that with two conditions, maximum elongation and allowable stress, you have to make sure that both conditions are met. So you sometimes what might happen, you only apply the formula for the allowable stress and you come out with this load. But then if you apply this load in this formula, you're going to exceed the 2 millimeters maximum elongation. So you have to apply, calculate the load out of the both conditions. And then the final result is the minimum between these two. And in this case, it's 1885 kilonewtons. That's it for today. I hope you found this video helpful. If you did, Don't forget to subscribe and give it a like, because this helps people just like you find me. Also, if you are interested in evaluating your education in this country, please make sure to click the link below and you'll be able to download the step-by-step guide on how to do that for free. Keep up the good work and I will see you next week.